Let's see how CPU request and limit work in a container. A pod is scheduled and then further the pod is created. Once the pod is created, the kubelet reads the pod spec where it finds the CPU request and limits. Once it finds the CPU request and limits, the information is passed to the container runtime, which is the container D, or a cryo, which is running on the worker node on which the pod is scheduled. Further, the Linux C groups are created with the CPU request and limits. Then further, the Linux scheduler comes into picture. If the CPU is less than the limit, the container will run, and if the CPU required is more than the limit, then the container is throttled. Now let's see what is CPU contention. CPU contention means that multiple containers or processes want to use the CPU at the same time, but the CPU is not enough for all of them to run simultaneously. So this means that if the CPU contention is yes, the CPU request will decide the priority. This means that multiple containers want to use the CPU, but there is not enough CPU available. Then the request is going to decide the priority. Otherwise, all the containers would run freely.